Well, welcome everybody. Thanks for coming out at 8 a.m. in Las Vegas. This talk is an introduction to vCenter operations. My name is Kit Colbert. I'm a principal engineer. I work on the vCenter Ops product. With me today is Marcelo. He's an escalation engineer who also works on vCops, specifically the enterprise version. So our talk today is going to start out with a bit of an overview, what vCops is all about, a little bit of background and context for why we did it, the problems that we're trying to solve with it, and so forth. Most of my part of the presentation will actually be walking through the product, talking about the different UI screens that you see, talking about the different concepts that are embedded in those screens to help you be able to understand and get the best use out of the product. Then Marcel will take over for some installation and configuration tips, sort of a tips and tricks summary. And then we'll conclude with a summary and hopefully have some time for Q&A. Okay, so when you take a look at the vCenter server, there's a whole bunch of data that's there. Performance charts, different sort of stats, disks, CPU, memory, all different sorts of breakdowns in different ways. And so there's a lot of data, a lot of numbers coming out of there. But the question is, what does this stuff really mean? Why are these things happening? And fundamentally, what do you do? So there's really a lot of data, but we need to take that data and create meaning out of it. And that's the overall goal of vCenter operations, is to boil down that mountain of data that we have to something that is consumable and actionable. In particular, we create these 3 different badges that I'll be talking about in the product walkthrough portion. So vCenter operations is based on an analytical model. We use analytics to actually learn the behavior of your environment. And then they can then tell you when that behavior changes, when you have problems, and alert you to that. Moreover, it can actually even tell you which objects are affected, what metrics within those objects, to allow you to start drilling in and finding out the root cause. And we couple this analytical model with some of our deep knowledge of vSphere. We built vSphere, we wrote ESX and VC. We know how these things perform, what the best practices are. So we built that knowledge into vCops as well. So there's really 2 different things. We have the analytics, and then we have this deep vSphere knowledge combined in vCops. And it's also important to note there, that last bullet, the third-party integration. This is not just a product for vSphere. This product actually supports any data you have, whether it's a storage array from NetApp or it's taking data out of another monitoring product you guys have like Tivoli or BMC. So we can pull data from anywhere, and that same analytical platform can be used for any type of data. Now there's 3 different editions that vCenter operation comes in. This first edition is the standard edition. It focuses primarily on performance, a little bit of capacity, a little bit of change, and it's just targeted at the vSphere platform. The advanced edition is everything in standard plus capacity management. So you get trending and forecasting, you get right sizing, both for VMs and hosts and clusters, and then reports. And finally, there's the enterprise edition. And the enterprise edition not only adds on full configuration, compliance management, but it also adds on support for any type of data that you have. As I said, the standard and the advanced editions are very focused on vSphere, customized UIs for vSphere. The enterprise product is actually much more general and can handle data from anything. Okay, so that's a very high-level overview of the product. Now let's start digging in a little bit. And I had debated as to whether to do a demo in here or just walk you through some of the UI screens. I myself prefer to play around with something rather than watch someone else do it. And so to that end, we have vCenter operations running in our booth in the expo. So I highly recommend you guys go down there and check it out. What I'm going to do in this talk is actually walk through some of the screens, talk about the different concepts that are in the screens. So that way when you go down to the booth or you download the appliance and play with it yourself, you'll have a better idea of what's going on, how to interpret the data, and how to get the best use out of it. Okay, so we're looking at the standard product. Again, the 3 editions, we're looking at the base edition, the standard edition. It's, as we said, targeted for vSphere, customized for vSphere, and indeed it plugs into the vSphere client UI. So the dashboard that you're looking at right now is the first thing you see when you log into vCops standard. And you'll notice a couple of things. That even though this is part of the VI client, it actually looks much different than other screens in the vSphere client. And this was intentional. The vSphere client is very good at object-based navigation, that you have some objects, a cluster you need to go to do something to it. But here, and with performance management in general, you don't always know where the problems are. You actually want the product to tell you where the problems are. So it's not just, you're not just going to go and click on every object and say, is there a problem, is there a problem? No, you want the product to say, hey, here are the problems. And that's what this screen is about doing. It's about showing you your entire environment in one at-a-glance view so you can very quickly understand, is my environment bad? Are there problems? If so, where are they? Now, even without understanding or having me explain any part of this yet, you hopefully have an idea about whether this environment is doing well or not so well, just by the coloring on the screen here. You see mostly green, and thus you can infer that things are mostly okay. A little bit of orange, a little bit of red, a few trouble areas, but overall the environment's pretty good. So what does all this stuff mean exactly, though? So on the upper left we have 3 different badges, 3 different ways of looking at your objects. And as I mentioned previously, a few slides ago, these 3 badges boil down hundreds of metrics of information to 3 simple ones that give you 3 different perspectives of how your object's doing. And we'll go through what exactly these mean in just a second. The next thing is that we don't represent objects as text strings anymore. In the VI client, they're just text strings on the left-hand side of the screen. Here they're actually icons, and they're colored by how that object is doing. So again, you can see most of them are green, most of them are doing pretty well. Finally, each of the objects, or each of the object types, are separated. So you have your VMs, your hosts, your clusters, and then you can tell how many VMs are having issues, how many hosts, etc. So this is the main dashboard. And again, the point being here that you can very quickly come in and ask, are there problems in my environment? And we can see here, it's not too bad. A few areas we need to check out, but overall it's doing pretty good. Okay, so now what do these 3 badges on the upper left-hand side mean? Well, the first one is health. What health measures is how normally the object is behaving. Again, this is based off our analytics. The analytics trend this object's behavior over time and learn what's normal for that object. Maybe it's low CPU usage, or maybe it's high CPU usage, or whatever. That becomes normal. And then when the object deviates from normal, when its behavior changes, health then degrades. And the notion being that that's usually an indication of a problem. So when health degrades, and we'll get into this in just a second as well, we actually show you which metrics are abnormal, what are their current values versus their normal values, and so on and so forth. So the system will actually tell you where to start looking. And one other point I wanted to make on the right here is that health is an interesting measure. It doesn't necessarily connote a problem per se, but it definitely is something that you're interested in, that you should be interested in checking out. Again, change doesn't necessarily mean that something's bad, but it means that it's something that is different, and you might want to investigate that. So one story I like telling is about one of our customers who uses actually the enterprise version of this software. And so they're monitoring a multi-tier app, very large app, many servers involved, both virtual, I think, and some physical. And so all of a sudden one day, the NOC, who are monitoring this app, they saw the health degrade really severely. It went from a health score of like 90 or so, 95 here, to something like 10. All sorts of metrics are going off. It was just crazy, right? So they started looking into it. Now, VCOps saw this, of course, and VCOps alerted them to this. This is how they knew about it. And what actually ended up happening, VCOps identified the stat that it believed was the cause that precipitated this cascade of abnormalities. And that one stat turned out to be the software version number of the application. That VCOps was monitoring the application, it monitored the software version number, and that changed. So what had happened? Well, someone had actually gone up and upgraded that software. They upgraded the software. There was new bits now. Those new bits behave differently. They use memory, CPU differently. They use the disk I/O differently. Thus, the stats that were monitoring that application changed. And they all changed pretty severely because we're doing a new application here, essentially. And so in that case, it was really interesting because it's not necessarily a problem that VCOps identified, but it was something very useful to the admins because they say, hey, I have now this effectively new application in terms of behavior. I need to go back and think about how do I provision it? Do I need to add more resources to it? So on and so forth. So again, health is a very useful measure for this because it tells you very accurately how normally is this object behaving. Okay, so now we have workload. So workload measures how hard an object is working. How hard is it using its resources? In particular, it measures two different things. It measures the demand for resources, how much an object wants, over its capacity for resources, how many it can get. And we just divide the two. So essentially, it's what it wants over what it can get. Now, obviously, if this number can go above 100, actually. It can want more than it's getting. A VM may want 2 gigahertz of CPU, but because it's running on a host with a whole bunch of other VMs, maybe it can only get 1 gigahertz. In that case, it's suffering. It's not able to do all the work that it'd like to do. And that is a performance problem. So this is what workload is trying to look at. So lower numbers are generally okay. Higher numbers, especially above 100, is where you start to get into issues. We look across all the 4 different resource types, so we do CPU, memory, disk, etc. And now the cool thing I like about workload and health together is that they're actually very useful and give 2 different perspectives that put together give you an idea of whether there's a problem or not. Workload is very absolute. It's measuring in an absolute sense how hard the object is working right now. Health is very relative. Health tells you how normally it's behaving compared to its past behavior. So what you can do is you can say, okay, I have a high workload right now. CPU is at 95% or something. Take a look at health. If health is high, that 95% CPU is normal, and thus everything's okay. But maybe health is very low, in which case you say, well, that CPU of 95 isn't that normal. So that's the other thing. We all have workloads that run really hot. Some workloads need 95% CPU. Some workloads need 90% memory. Some workloads need very high disk I/O rates. Using static thresholds, you might trip over those because CPU above 90 is bad, right? And those just don't work. So the nice thing about VCOps is what we do is we give you both an absolute measure, but also this relativistic health measure that allows you to know how normal things behaving, and thus, is it okay or not? Our third badge is capacity. And capacity, unlike health and workload, is really projected forward. Health and workload measure now. Capacity is saying, let's look forward. How much risk is there? And essentially it measures how much time you have left before you run out of capacity. Like workload and health, it's based on a 0 to 100 scale. The higher the number, the more time you have. We've pre-configured it such that when capacity hits 0, and the button will turn, or the icon will turn red, you have about 30 days left before you will exhaust your capacity. Pardon me. Like workload, it also measures all 4 resource types, so we can look across all aspects of that object to see when it's going to run out. So those are the 3 badges, and they are a very prominent place there on the upper left-hand corner of our dashboard. Now, getting back to the dashboard, the cool thing about this dashboard, one of the things I actually really like about it, is that it's not just some passive thing that you look at and then you drill down to the next level. This dashboard also allows you to do the first level of triage on a problem. So what I've done here is I have selected one ESX host. It was orange. I decided to click on it and check it out, see what's going on with it. So you notice a couple of things when I did that. First thing is you get this little pop-up here in the right-hand corner that shows you all the different badge scores for that object. So you know what its health is, you know what its workload is, and you know what its capacity is. So very quickly, I can tell what's going on with this object. Its workload, pretty low, 40-ish, I guess not low, but not high either. Health is actually pretty degraded, so something's different about this. The behavior has changed. But its capacity is 100, so I know it's not a capacity shortfall problem. I think I'm okay there. But this health issue is a little bit worrying. So again, you get that first level of detail. Now, the other thing I really like is that we actually highlight all of the related objects to this one. So this one's a host, and you see which VMs are running on that host. Now, this is really useful because you can very quickly tell, is this a problem across the entire host? Is this affecting all my VMs on the host? Or is it just a few? Is it a population pressure problem? Is there some noisy neighbor that's causing this issue? You also get into the victim versus villain question a little bit here. Is one of these VMs causing this problem, or is it suffering because someone else is causing it? So we can tell here that it doesn't seem like it's a very widespread issue. Only a couple of the VMs on the host are not green. So thus, it may be confined to just these 1 or 2 VMs here. So again, the point here is that this dashboard is great for taking a look at your entire environment, saying, where are my problems? Then you can select an object, get a bit more detail about it, and do a first level of triage, trying to find out, is this object actually the real issue, or is it some other object that's affecting it? So that's what this dashboard allows you to do. Now, let's say we want to drill in and get more details about this host that we're looking at here. So then we come to the details screen. So the details screen is that next level of detail about whatever object you're looking at. Now, let's walk through this. Upper left-hand corner, you'll see that it's the same 3 badges as before. And as a matter of fact, in the lower right-hand corner, that section, that's actually a details area that gives you more information about which badge you've selected. And we'll go through this more in a second. But if you look directly below the badges, you'll see another useful piece of information. And that's a breakdown of the workload by the resource type. This allows you, again, to very quickly figure out where the problem is. Is it a disk problem? Is it a memory problem? What's the issue? In this case, it's very obvious that it's a disk problem. And by the way, workload, 170%. As I said, workload can go above 100. So what does this mean, 170%? Well, what it means is that, in particular, in this case, disk, it wants 170% of what it can actually get. Its demand is very high, but its actual usable capacity is not that high. There's something blocking it, something not allowing it to get as much as it would like. Thus, we can tell very clearly that this thing's suffering a performance issue. It's way out of the ballpark here. As I said, this section here contains details for the selected badge, and we'll go through that in more detail in just a second. Okay, now, since it's a disk I/O problem, we can shift to the bottom half of the details page and see a little bit more information about what's going on. One of the things I really like, one of these visualizations, is this top one here. What this top one does is actually show you the trend, the history of the thing you're looking at. In this case, it's workload. And it overlays events on top of that performance chart. So what it allows you to do is allows you to correlate event occurrences with performance problems. Now, in this case, you can see a couple of events there. Didn't seem to affect workload too much. Workload stayed pretty flat, a little bit of a spike. But if you were to see workload go way up or way down or something change visibly, then you might investigate what that event was about. What change happened? So this is taking change information and overlaying it on top of performance data to allow you to say, did this change actually cause my performance issue? Now, getting down to the storage section here. So we have both storage and network. The storage section allows us to break it down in a few different ways. We can break it down by virtual disk. We can break it down by the data store that this object is talking to. We can break it down by the LUN that this object is talking to. You see the capacity for, we selected data store here, and so you can see the capacity there on the left, that green shape there. And we also give you a whole bunch of information about the I/O to that data store. So there's 2 sets of I/O here, I/O data. There's a top set, those first 3 stats. What that is, that's the total amount of I/O going to the data store as a whole. The bottom one is actually how much this object is contributing to that data store. So if you can't read the numbers from the back, the I/O to the data store is about 30,000 IOPS for read and write. For the throughput, you're looking at about 20 megabytes per second for read and write. And then the latency is actually somewhat high, 17, 18 milliseconds. Now, so that's for the data store as a whole. So what is this VM contributing? Well, we can see here. The VM's contributing about 1,000 IOPS and about 13, 14 megabytes a second. So the VM's actually not doing that much at all in terms of IOPS. It is actually contributing a significant amount of the throughput. But here's another interesting thing that VCOps does. Look at these little icons here on the right. These icons actually tell you whether these stats are normal or not. Again, VCOps looks at all this data, the thousands and sometimes millions of metrics coming in from your environment, and it trends them all. So it knows about everything, and it knows whether those things are behaving normally or if they aren't. So in this particular case, it can tell us, hey, for this data store, this is not normal. In particular, there's a slight up arrow. This thing is above its normal threshold. So what does this tell me? Well, there's also a lack of that icon by the VM. So the VM is actually behaving totally normally. It's within its normal range. That data store, though, is way above. So what do I know because of that? Well, I know that someone else on the data store, maybe a number of other VMs on that data store, are pushing a lot of traffic to it. Maybe they're causing the issue. So again, this gets back to the victim versus villain question. In this case, this VM, or this object here, looks like a victim and not the cause of the problem. The other thing is maybe hard to see, especially from the back, is that we actually do have a gray sort of background that we show where the normal baseline is. So for the VM, it's almost all gray in the background because it's completely within its normal range. But for the data store, you can barely see any gray at all because it's so far above its normal range. So again, this is what vCOps does. It's looking constantly at all your data and then it's telling you when things go abnormal so that you know and can use that to say, okay, where is this problem at? Who's causing it? Now, let's go back up to the top here and dig into some of the details. So again, for each badge you select, whether it's workload, health, capacity, you get some details about that. Why is the health score the way it is? So what we do in vCOps, in the health scores, we list all the abnormal metrics for you. And we list them in the order in which we think that they're the problem, or they're the source of the problem, and the order in which you should investigate them. And we tell you whether they're above or below threshold. We give you very specific sets of data. I think in this particular case, this is a bunch of data store stats. I think this is the same data store that we were looking at in the last slide. And so we can see here that everything's above normal for this data store. The read rate's way up. The read rate, as a matter of fact, is not only above its dynamic threshold. Its normal dynamic threshold is set at 164 kilobytes a second. This thing's doing 26 megabytes a second. So it's way above normal. But this is what vCOps tells you. So out of the millions of metrics in your data center, we can get down to a very small subset, in this case 5, that tell us what's going on, where we need to focus our attention. Capacity. Capacity is looking forward, how many days you have remaining. And it does this on each resource type, CPU, memory, disk, network. And so for each of them, it projects a breach date. So we can see here that disk has 138 days before it breaches. CPU's only 8 days, and memory is actually at 4 days. So I've selected disk here, and you can see that we actually graph both the historical behavior and what we believe to be the future behavior. And sort of hard to see, but it's an interesting pattern of the way the disk was being used, sort of up and down motion. And you can see how that's projected forward. And then when that graph crosses the 100% point, that's the breach date. In this case, vCOps was forecasting a breach date of July 3rd this year. This data was taken earlier, obviously. So hopefully someone fixed that before it ran out of capacity. Oops, sorry. Okay. So then we have workload. So workload breaks down the workload value for you, essentially, to tell you why it is the way it is. So with CPU and memory, the top bar graph here shows you usage and demand, these sorts of things. Again, we talked about demand and how that's part of workload. The bottom graph shows you a breakdown by VM. Which VMs are using this resource? So again, this gives you a very clear idea if some VM is just, being a noisy neighbor, essentially, and just eating up all the resources. Now, we have a bunch of these stats. Demand, usable, usage. There's a whole bunch of terms here that you might not be familiar with. And we actually did this intentionally. We moved away from some of the stat names in VC, partially because the stat names in VC are not very consistent at all across metrics. You have CPU ready, but there's not memory ready or disk ready or any of that stuff. So we wanted to get something a bit more consistent so that you could learn the terms once and then not have to worry about it whether you're looking at disk or memory or CPU. So here are the terms that we've come up with. And you'll see these terms throughout the vCOps UI. So we have provisioned. Provisioned is the total amount of the resource that's been provisioned. So for a VM, you give it 4 gigabytes of memory, that's the provision size. But then there's usable. So usable is the amount of a resource that's actually usable by VMs. So take a host. You install 16 gigabytes on a host. Can VMs use that whole 16 gigabytes? No. And why? Well, there's a service console that's running that takes some memory. The ESX host itself takes a little bit of memory. If you have HA and you have failover configured for it, that takes the memory in terms of the buffer. So maybe you're down to 15 gigabytes or even less of usable capacity. So it's really important to understand how much you actually have that you can use. So that's where this usable concept comes from. Entitlement. Entitlement is a measure of how many resources, physical resources, a VM can get based on its fair share with other VMs. So again, you configure your VM with 4 gigabytes of memory. Does it actually get 4 gigabytes of physical RAM? Not necessarily. It may get much less, especially if the host is overcommitted on memory. So entitlement gives you a very clear idea of what this VM is actually entitled to get. Then we have usage. Usage is essentially how much of the resource the VM gets. We have demand, as I talked about previously. Demand is what it wants. So usage is what it gets, demand is what it wants, and entitlement is the most it can get right now. So we can see very clearly that if demand exceeds entitlement, that's a bad thing, that this wants more resources than it's entitled to. In that case, you may need to rebalance some VMs, set some reservations, etc. Finally, we have contention. So contention is a measure of, in most cases, latency. How much is this VM being affected in terms of its performance by not being able to access physical resources? So if the VM has to swap memory, for instance, that would show up in contention. So contention is a very good indicator of, is this VM suffering a performance problem? In particular, contention would be CPU ready. For CPU, we have a new memory latency one that we can use for that. So these are the new terms, and the nice thing about them is that they're consistent across all resource types and all objects. So once you learn them once, then you can apply them anywhere. And let's take an example here of these new terms. Pardon me. So I've graphed a few different metrics here. The first one is provisioned. Again, this is a VM we're looking at in memory in particular. So you can see we provisioned 2 gigabytes of memory for this VM. And that's pretty constant. Not too interesting there. Entitlement and usage actually happen to follow each other very closely. So they're actually overlapping. And then we have demand down there at the bottom. And so if you notice, demand stays below usage for quite a while. But then you see this spike in demand on the right-hand side here. And you see demand actually go above entitlement and usage. Now, I actually set a memory limit on this VM just to show you what happens here. You can see how demand goes up above, but entitlement stays low. Entitlement does not go up to meet that demand. So what does that mean? Demand is greater than entitlement. The VM can't get everything that it wants. That means it has to wait. It has to wait a little while for that memory. And accordingly, you can see contention here on the bottom. See how contention is flat as long as demand is less than the entitlement? But once demand exceeds the entitlement, then you start getting contention. This VM is swapping or ballooning, and thus having to wait a little while before it can access memory. So you can see contention shooting up because of that. Now here's the cool thing about this graph. That happens to be about a VM's memory, but it could be about anything. It could be about a host disk or cluster's network. All these same terms apply. So this is a really useful thing. Once you understand these terms and sort of how they work, then you can apply it to any set of data. Okay, the final screen I wanted to go over is the analysis screen. So the analysis screen is for asking very open-ended questions about your environment. We actually use a visualization here called a tree map, and it's a really good way, a very compact way of showing and representing a lot of data. So what is this particular one we're looking at here? Well, these little boxes are VMs, and they're sized by how much CPU they're using. Then they're colored by how much contention they have, how much CPU ready, essentially. So you can very quickly see a few things. First of all, by the size of the boxes, you can see who the big VM users are. But the more interesting one is actually the color. The color jumps out at you very quickly. How many VMs here are contending on CPU? The answer is pretty simple. It's 2. There's a yellow one, has a 12% or so contention, and then we have this bright red one. So if we're thinking about where to look first, we'd probably look at this red one and drill in and see what's going on with that guy. Now the cool thing about this visualization or this page here is that we have all the different objects. I mean, for instance, that data store problem that we saw before, there's a visualization for data store to see who are the users on that data store. So we saw that data store was being used and it was above normal, so we could go over here and say, okay, who are the users on the data store? Who are the big heavy users? And then drill in and see what those guys are doing. It works for hosts, for clusters, for any type of data, CPU, memory, network, etc. And, well, there is a customize button here. They moved these little things on me. But there's also a customize button, so you can actually make your own. Again, it's any stat that VCOps collects. Okay, so that brings me to the end of my section. Now I'll bring up Marcelo.
Good morning. My name is Marcelo Rodriguez, and I work for the Global Support Services Organization. I'm the escalation engineer for vCenter Operations Enterprise, and I'm going to go ahead and take you through a few installation and configuration tips. It's just basically we at VMware want you to have a very positive experience with the product, and we're going to go ahead and tell you how to go ahead and bring it down, what some common configuration issues that we see in support are, and just a few tips to go ahead and get you started. It is fairly easy to get. It says easiest 1, 2, 3. The free trial of VCOps standard is at vmware.com/go/ and I'm going to say this at times is VCOPS, is what the acronym is. But it downloads as an OVF. It is fairly easy to install, just like some of your other plugins that you have to vCenter. It is, one of those file deploy OVF, fairly easy. It deploys to the vSphere's clients. And all you really have to do is configure the vCenter information on it. It'll begin collecting metrics immediately. Few things about this. The UI that we were talking about is for normal operations. And then not only can you go and get this screen through the vSphere client, but it's actually also a URL that you can go ahead and hit and then bring up the UI, the dashboard that you see there. Besides that, there's a couple of other UIs which are important. One is the appliance administration, basically what is the OS administration, where you set up the IP address, the DNSing, time zones, everything to go ahead and have your vCenter operations configured correctly to go ahead and talk to your vCenter. And that is on port 5480, but you also have a screen, a little link on the next screen, which is the appliance administration. And in the appliance administration, that's where you can go ahead and do things like set up the vCenter, upload your SSL certificate for your organization, set up take a look at the self-monitoring. Just like it monitors other things, there is actually a section where it monitors its self-health so that you know how it is performing as an appliance. So for the three things that you need to go ahead and do to go ahead and get this running is whenever you open up that plugin in your vSphere client, or if you go to the IP address, the first thing that it's going to go ahead and ask you to do, it's going to prompt you for a change in the default password at first logon. The default username and password, when you bring it down, just in case you forget, we get this a lot of questions. It's like, how do I get into the appliance? Admin. Fairly easy. The initial change, this is one is pretty important. Write this, that password down, store it in your KeyPass or whatever utilities, because the initial change will not only change the application administration main main password, but it'll also change the root password for the appliance. This runs on Linux, so whenever you do hit that other screen where it goes into the appliance administration, no longer will it be the username be admin, but the username will be the root password on there. The second thing is to configure the vCenter info, and it's basically it's fairly easy, but it does ask you for two sets of credentials. One of the credentials is the registration and the collection password. For security hardening on your organization, you may be asked, like, hey, we don't want to go ahead and run this as an admin all the time. You can go ahead and put in the same account in both. We recommend that you split them out. That way you know what is hitting your vCenter and create basically a username for each one of them. The first one is the registration. The registration has to be part of the administrator role because the administrator role is what allows it to go ahead and register onto vCenter. But it's only going to go ahead and use that really for the first time, for just registration through it. The second set of credentials is actually the important one, where it's going to go ahead and use to connect to your vCenter, pull information out, and this one must have a minimum of read-only through it. And we're going to talk about where to go ahead and set that information up in your vCenter here in a little bit. You also want to go ahead and, as the third step, is set up the OS configuration. By default, it grabs DHCP, but we really highly recommend, even if you're doing just a trial, to go ahead and set it up with a static IP address. It prevents you from having to go ahead and reconfigure it on your environment in case you've shut down the appliance, it's lost its lease, and it comes back up, and now you can't. The vCenter vSphere client or the URL no longer works, and you cannot get into the application again. Here's a couple of common configuration issues. One of the big ones is the minimum version is not met. The minimum versions are vCenter 4.0, Update 2. Okay, you have to go ahead and get that minimum level. If you don't have that minimum level, we have a few strange behaviors that may happen, including multiple sessions on your vCenter, so you make sure that it does meet this minimum standard, or vCenter 4.1. The second common configuration issue is the permission scope is not configured correctly. So vCenter Operations supports up to about 1,500 VMs. And what may happen is that the vCenter may show a question mark, which is basically an unknown status across your whole screen with a lot of the resources, or with a partial set of resources. Part of why this may be is that it may not have been configured with permissions from the top of the level of the vCenter down. We highly recommend to go ahead and apply those permissions from the top level all the way down, because that's so important for it to go ahead and grab information, as Kit had pointed out, to take a look at root metrics to figure out whether there's a villain in your VMs, or some VM is getting victimized by another VM, because what will happen is that if you hide one of those sections, that one that's hidden may be taking a lot of resources, and it won't point you in the right direction to go ahead and diagnose the problem. The account can either be a local or a domain account. We highly recommend to use an account that is dedicated to VC Ops. That way, when another administrator is using, for example, another account on another application, it does not conflict with it, and you can quickly diagnose why your vCenter operations may not be connecting to your vCenter. And actually, I'm going to go back to this slide here for a second. And like I said, on the bottom here, it is, you can hide some of the resources, but really we only recommend that if it's a lab, it's not connected to anything else that will be a common resource, such as it's a lab instance that doesn't share network, doesn't share I/O, doesn't share the data store, doesn't share really any other resources. If it does share it, we want to go ahead and be able to monitor the entire thing. couple of other configuration issues why you may have it is NTP and time configuration. We highly recommend NTP to keep it synchronized with the vCenter and to keep it synchronized with the client, because any incorrectly stamps, it uses timestamps, and anything that is incorrectly configured on those timestamps, it may go ahead and drop that metric. It may not show it to you real time because it thinks that it is old data. It will still go ahead and do the dynamic thresholding overnight. However, it will not go ahead and show you current status of health, current status of capacity, and any of those metrics. The other one is DNS not available. If you don't have it on that network, even if you're trying it out, you have it in your lab or dev environment or test environment, if the DNS is not available, because of the way that we handle the firewall, it won't be able to basically talk to itself because it thinks it's an unknown machine. DHCP and static addressing. You can go ahead and use the DHCP when you first install it, start it up. It's going to go ahead and grab the DHCP address. You can go and configure it right then and there. But we recommend, once again, to go ahead and shortly after that, change it to a static IP addressing scheme, set up the time zone, and set up the appliance information so that the application on it can go ahead and run fairly smoothly, and you have less issues with it losing the connection. I'm going to go ahead and hand it back to Kit, and then after that, we'll go ahead and take some questions. As we said, the vCenter, this vCenter operations does connect to vCenter for the standard, but we can go ahead and hook it up to a lot of different metric data sources. And if you have questions about that, we'll be able to go ahead and answer those also. Good?
Thanks. Okay, just a real quick summary here. So, as we've been talking about, VCOps brings together three different disciplines: performance, capacity, and configuration. We have our advanced performance analytics that learn normal behavior, combined with deep vSphere knowledge that we can use to tell you when something really is good or bad. Capacity analysis. You didn't see the full capacity here because I was just looking at the standard product. But even in the standard product, you do at least have some basic capacity forecasting. But with the advanced edition comes right sizing, a lot more analysis there, and then configuration, looking at change tracking, correlating events to performance issues. So that's the talk for today. We can take Q&A now. Any questions? So the question is, if you can stand by the mics, it's better. I can repeat your question. What database does it use? So the standard edition is packaged as a virtual appliance, and it actually uses the Postgres database. But the enterprise edition is, what do we support? Oracle, MS
we support Oracle and SQL Server. For the standard edition, it uses a couple of different databases, including a file system database that we use locally, and Postgres is the configuration database.
And by the way, for those people that are leaving, let's see if they... Yeah, so if you can be sure to fill out the survey. It's really useful both for VMworld in general and for us as presenters to know what to do better, what to change. Okay.
Yeah, I had a question about the way you calculate normalcy and baselines.
Okay.
And I think in the olden days with the enterprise, that made a lot of sense. 8 a.m. in the morning, there was a peak, and 10 a.m. maybe. In the cloud, with such random usage patterns, how useful are your customers finding the normalcy? Is there something normal for eBay, for example, or Amazon? Is there a normal pattern?
Oh, yeah, definitely. So there's a couple of things. So there's always going to be some normal patterns. Now you may have, for certain behavior, for certain metrics, you may have very wide, just because at any time it could be up or down, you don't know. So for things like eBay, so what's eBay running? So they have some massive application, right, that is their website. And so they're going to have some multi-tier system there. They're going to be monitoring all that. And lots of customers do exactly this. So it's very large scale, very large application, combining millions of metrics into a single application, really. And so people do that today, and it works really well. It's really good at looking at all that data and filtering out the noise so that you find problems. It's not, what you should do if you're really interested in it is come to my other talk. It's a VCOps deep dive, and I actually get into a little bit about how the analytics work. Because it's easy for me to tell you, yeah, it works, but okay. It's better to see a little bit of how it works. Okay.
How long do you normally recommend maintaining the metrics, and what sort of disk space are you looking at to store all that?
Okay. How long to retain the metrics? So with the standard product, we set a default of 6 months. And I don't know what do we do with enterprise?
With the enterprise product, it'll keep for 900 days as the default. But it is configurable to say when it does the cleanup and how many days it is to keep. The longer that you keep it, the better the metrics will be, because it'll do day by day, week by week trending, month by month trending, quarter by quarter trending, and year by year trending. So
in terms of the space, it's actually, Marcelo referred to this. So we have both a relational database to store things like configuration data and object information relationships. We also have a special database just for time series data for all the stats and metrics that we collect. It's something that we wrote ourselves. We call it the FSDB. It's basically a file. It's just composed of flat files, essentially. And that one stores all the time series data, which is obviously the bulk of the data that you have to store. And the bulk of the space, but it's actually extraordinarily efficient in terms of how it stores it. I think the overall cost is 16 bytes per metric observation. So you can do the math. You're getting many customers are in the millions of metrics every 5 minutes. You can very quickly do the math. In terms of a year, we estimated about 2 megabytes per stat per year of storage. So, but it's very dependent on what your environment is, how many stats you're collecting, and that sort of thing. That's some back-of-the-envelope calculations.
By default, how many stats are collected per either host or VM or something like that?
So it's in the neighborhood of 200 or so for VMs and hosts. Hosts, again, it depends. That's the standard engineering answer. But there are certain things that can just blow you out of the water with hosts. Things like the path, like if you have a 4.1 host and you get storage path data, and you just have some customers just have 100 data stores connected to a single host or visible by a single host and just tons of paths. And so that can really bloat the number of metrics that you're collecting. And so we've done some tuning in standard to try and reduce that, to try and get it somewhere reasonable. But again, it depends on how many devices are connected, and then based on that you can, But again, it's 200 or so as a base. It can go up to easily 1,000 depending on your configuration.
So early on the slide, you showed how you take past history and extrapolate it to kind of see how many days which you read the top.
Yeah.
How do you decide what piece of the history to duplicate? Because depending on where you take a start and finish, it may go up and down. So how do you calculate which one to replicate going forward?
Yeah. So the capacity analysis is a special type of analysis. I don't actually know exactly how it works, to be totally honest. I'm not the algorithms guy, but let's talk offline.
Okay. Now, is the data that you use the same for your performance as well as capacity?
Yes.
Or do you pick up different? Okay.
Yeah, it's the same data. We actually what we do is we actually do have it in different granularities, though. Because performance data for the analytics to work best, they need to stay in their raw format. So we don't do any roll-ups of performance data. Capacity data, on the other hand, we do a special type of roll-up that allows it to maintain its granularity over time, but significantly reduce the storage space. So for capacity, we actually want to keep like 10 years of data, but at a very reduced storage space. So,
thank you.
I've got kind of two questions for you. One is, when you were asked about which database you used before, you said for standard that you use Postgres, and that for enterprise, I think you said you use any of the major players. What's being used for the advanced, and how is that going to change?
Sorry, yeah, advanced is the same.
But then how does that affect when the change is going to come here in October with the standard and advanced changing?
Okay, yeah, so advanced is the same as standard. It uses Postgres. It comes as a virtual appliance. So what we're actually trying to do, so you're basically talking about what happens if you try to upgrade from advanced to enterprise, that sort of thing?
Well, so if I get advanced today, I'm going to end up with 2 VM appliances, right?
Yeah.
Later this year, I understand that's the advanced will actually become a single VM appliance.
Well, single virtual appliance, which happens to be 2 VMs, but yes.
So
Now,
is that data, like if what gets created in that database, can I attach to that with the new version of Advanced when it comes and just shut down my existing 2 VMs?
yes. Yeah.
Thank you.
Yeah, we're definitely, I mean, we're going to support that upgrade path, yeah.
Yes. Earlier, you mentioned in health, you determine health by demand over available. How do you measure demand?
No, sorry, that's workload. Workload is demand over the capacity, this entitlement, essentially.
Okay.
So,
Okay.
so how do we determine demand?
Right.
Very carefully. It's tricky. It is. So all the data we have. I mean, so the interesting thing about VCOps is that we made a decision a long time ago to not be in the business of creating new data sources. There's tons of data sources out there, and we just go and get them and then get the data. So we're sort of at the mercy of the data source to give us good, useful information. In the case of VC, we're at the mercy of the Performance Manager API to have the right stats in it that we can use. Now, CPU demand is actually pretty straightforward. That data is already in there. Memory demand is not really there, so we have some data around it. We don't have quite everything we'd like to get, so we have to, fudge a little bit. Not fudge, but try to infer as much as we can. So there's a whole bunch of internal equations and algorithms that we use to try and compute demand. And we do it for network, and we do it for disk, and so forth. So it is, it's part art, part science to getting that demand metric. But we do extensive testing to see if that matches up well with real-world behaviors. And so far it has. And we're always going to try and tune them and improve it. But, yeah. So it's a good question. It's a challenging problem.
Okay. Second question. How much resource would I need to run VCOps?
The standard edition, it's a virtual appliance, 2 vCPUs. I think it's 8 gigabytes of memory. And then for the storage, I think it's like 125 gigs. For the default, 1,500 VMs over 6 months or something. I think that's pretty much what you're looking at.
All right. Thank you.
Mm-hmm.
One question I have is around performance of VM. So if the VM performance is slowed down because of the number of snapshots that VM has taken, does VCOps capture that?
If it's slowed down because of the number of snapshots, I mean, we would definitely, we definitely notice that it's slow. I don't know if we'd be able to say it's because you're running too many snapshots. I don't know. I don't know how that would actually show up in the VC stats. Because again, we're at the mercy of whatever stats VC has. So, could we do a correlation between snapshots and utilization? Right. So, I mean, it is possible to know sort of, this VM happens to be running a disk that has a bunch of snapshots, and if it's slow, that may be because of that. Yeah. We're trying to build in more knowledge like that uses these sort of inferences. But today, we probably wouldn't be able to say accurately that it is a snapshot. And I think partially because VC just doesn't break down that data for us like that. Now, again, like this gentleman was saying, we do have the information that this VM has snapshots and that is powered on and running a disk with snapshots. We wouldn't be able to precisely say that poor performance is because of that, but we could at least suggest that possibly. So that's still one area we haven't really gotten to yet.
Okay, thank you. And one more question around the UI.
Okay.
So it's in a real cloud environment, is the UI configurable, the dashboard that you saw VCOps, typically when you're dealing like thousands of servers and 10,000s of VMs,
right?
The front page dashboard that you saw, is there a way that you can group it some different way, or it'll just show like a big blob?
Yeah, so today the standard UI is not configurable. The enterprise UI is, completely configurable. You can do sort of anything. Now, the standard UI actually does, in my opinion, it does actually scale pretty well to very large environments. The icons will get smaller as you get more objects. There's also a number of filters I didn't talk about, but there's on the upper right-hand corner, there's filters. So you can say, you know what, I don't want to see any green objects. And that will significantly reduce the population that's there. So there are different things you can do with it. So, we show the screenshot, and it's like for a very small environment. But I found, or at least in my opinion, I think it does scale pretty well to very large environments even.
Thank you.
There's There's also there's also another button that you saw there in some of those metric screens that'll go ahead and say all metrics, and then in that screen it basically reverts back to kind of a classic view of what you'll see in the enterprise product. And it's for large environments. Sometimes it's easier to go ahead and navigate through there because it'll do a subset of your environment.
Okay. Thank you.
We saw some very fancy screenshots of the keynote yesterday. Is this it, or what is the difference?
Screenshots at the which keynote?
The second keynote, your
Steve Herod? See, he had,
some VCR screenshots towards the end.
they put VCR screenshots in there?
I didn't know that. No,
I didn't see it.
I didn't see it. Sorry,
I missed it.
we're probably in sessions.
I went to the lab.
Okay. Yeah, so that's a product, called Navigator. It's not. That's actually a bit different than VCOps. It's in the same space. Okay. Well, right now they're separate. I mean, we're planning on merging them, I'm sure. It's a big company. Things move fast. I don't know. So sorry. I don't know. We are working hard on our next release of VCOps coming. Well, I don't know when I can say it's coming out, but and there's a lot of things we want to integrate. Navigator is one of them. So I don't know the exact timelines though. Okay.
And please stop by the booth, play with the VCOps demo station there in the VMware booth. And there should be some folks to go ahead and help you. VCOps, I will be there in the booth this afternoon and tomorrow morning. So if you want to go ahead and come and ask me more direct technical questions, you can definitely stop by, and we'll try to go ahead and answer your questions individually.
All right.
That's it. Okay, thank you.